So this is a brief video on the topic of buffers to help those of you who are going to move on to do a science-related degree. And we're going to look at what buffers are and how we make them. There's a couple of ways we can make buffers and also how to explain how they work. So you've probably heard of buffers, which are basically solutions that minimize the change in pH of the solution. So they're basically a mixture of a number of things that does this. However, they only minimize the change in pH if you add small amounts of acid or bases. It won't minimize the change in pH if you add too much acid or too much alkali. So how does a buffer work? Well, a buffer is really a mixture of a weak acid and its conjugate base. And the weak acid you choose is dependent on what pH you want to buffer, and we can look at that another time. But for today, let's look at how a buffer works. So I'm going to scroll down to the equilibrium equation for the buffer, which looks exactly the same as for the weak acid, but the concentration of these components are different. I'll go through how we make buffers in a bit, but let's see how a buffer works first. So in a buffer solution, you have a mixture of the weak acid and the conjugate base as well. So it happens that you make up this solution, so you have a high concentration of the weak acid and a high concentration of the conjugate base. So the buffer will work like this. If you add a bit of acid to this buffer mixture, according to the Chitalis principle, the equilibrium will shift to the left-hand side. And this is possible because we have a high concentration of the conjugate base to accept those added protons and shift the equilibrium to the left-hand side. We can't use a weak acid as a buffer, even though the equilibrium equation looks identical, because there may not be enough conjugate base in the solution of the acid to accept those added protons. So even though these looks identical, a buffer is very different in terms of its components. So if we add an alkali, what happens would be that the alkalis will remove the protons in the buffer solution. So this decreases the concentration of the H plus ions, and the equilibrium will shift forward then to replace those H plus ions that's been lost. This is possible for a buffer because we have a high concentration of undissociated acid to release protons to replace what has been lost by the added alkali removing those protons. So obviously we can't just use the weak acid as a buffer. So let's see how we can make a buffer with a high concentration of conjugate base and high concentration of undissociated acid to accept or release protons to buffer the solution. So there are two ways to make buffers. So one way is simply add the conjugate base or the salt of the acid, which is basically conjugate base, to the weak acid itself. So I would have the weak acid and I basically add the salt of the weak acid. So for example, if I have ethanoic acid here, I would add sodium ethanoate salt to this acid, and that sodium ethanoate would ionize completely because it's an ionic compound and would dissolve very well in aqueous solution, and that would provide a high concentration of the ethanoate ions. So I will have a high concentration of the conjugate base, the ethanoate ions, with the high concentration of the undissociated acid, the ethanoic acid. So that's one way of making a buffer. So to clarify, we have a mixture of weak acid, like here we got ethanoic acid, and it ionizes to give us a low concentration of H plus ions and a low concentration of conjugate base if I just got the weak acid on its own, because a weak acid only ionizes partially, so the concentration of these two will be quite low. If I mix a salt of the acid or the conjugate base, so here's the salt of the acid, this is sodium ethanoate. A salt of the acid ionizes completely because it's very soluble in aqueous solution. It will ionize completely, and we have a high concentration of both the conjugate base and the sodium salt, but we're not interested in the sodium, it's just a spectator ion in the buffer. So mixing these two together, we have a high concentration of the undissociated acid from the weak acid, have a high concentration of the conjugate base that comes from adding the salt of the acid. So we have a low concentration of H plus ions from the acid. Another way to make the buffer is, rather than just add the salt directly to the acid to have these two components, we're going to make the salt in situ by adding excess weak acid to an alkali. Well, what happens if you add an excess of weak acid to an alkali? Well, you're going to have the alkaline reacting with the weak acid to make the salt. So you make the salt in situ, and then because you've got excess acid, you have the acid as well. So that's another way of making the buffer. So next thing I'm going to do is talk about what you need to write in the exam to maximize the chances of getting the marks when you explain how a buffer works. And the very first thing you should do is write the equation, the equilibrium equation for the buffer that you're referring to. So always write the equation and label it buffer equilibrium or buffer equilibrium equation, because it makes it a lot easier for you to explain your ideas. So in this example, I've got a buffer made up of methanoic acid and its conjugate base. So this conjugate base could have been by just adding potassium methanoate to the methanoic acid, or we could have added some alkaline to excess methanoic acid to make the salt, the conjugate base. So we could have added sodium hydroxide and we'd make some sodium methanoate, and the excess acid would be providing the undissociated acid in the buffer. Once you've written the equilibrium equation, you can then refer to it in your explanation. So for example, if you want to explain how the buffer works when you add an acid, you would say something like, when a small amount of acid is added to the buffer solution, the added protons will combine with the conjugate base, in this case it's the methanoate ions, and the buffer equilibrium shifts to the left-hand side. So this is why you need to write down the buffer equilibrium in order to refer to the left or right-hand side of the equilibrium equation. And the equilibrium shifts left-hand side to remove the added protons or H plus ions and therefore minimize any change in pH. If you explain in terms of what happens when you add an alkaline, you would say when a small amount of alkaline is added to the buffer, the added hydroxide ions combine with the H plus ions in the buffer or from the buffer to form water, and the above equilibrium shifts to the right hand side. So because you've written the equilibrium equation, you can refer to it. If you don't write that down, which lots of people forget to do, you're not going to be able to refer to equilibrium, and you're just talking about shifting left or right. And the examiner's thinking, what do you mean left or right? Left or right of what equilibrium? Because you haven't written the equation. So by shifting forward to the right hand side, the equilibrium will replace the H plus ions that you removed and minimize any change in pH.